Hello, everybody, and welcome back to another Mr. Farney Earth Science video. This is our final video of our meteorology unit, where we're going to be focusing on severe weather. We're going to talk a little bit about tornadoes, how they work, a little bit about hurricanes, and then a brief discussion about how even though you might have weather patterns in place that don't seem too intense, if they persist for a really long period of time, they can be detrimental to their surrounding environment. So firstly, let's go a little generic and then we'll get specific. So we're going to talk severe weather in general here. And the main idea here is that all thunderstorms can produce wind, rain, lightning, and have dangerous damaging effects depending on certain circumstances. So the first term that we're going to learn is supercells. And what are supercell thunderstorms? They are extraordinarily strong thunderstorms that have intense rotating updrafts. And what does that kind of sound like? Well, if you have rotating wind, kind of sounds like you might be able to spawn some tornadoes from that. Supercell thunderstorms are known to spawn multiple tornadoes. Luckily for us, only about 1% of all thunderstorms annually are supercells. So very small percentage of thunderstorms are supercells. And of those supercells, not all of them are going to spawn tornadoes. How does this work? Excuse me. The more unstable we make the air, the stronger the storm's updrafts and downdrafts are going to be. Now, we learned in the last video that in the mature stage of the thunderstorm cycle, the updrafts, downdrafts are going to be side by side. So the more unstable it becomes, the stronger the wind movements are going to be. So that's kind of how some severe thunderstorms are stronger than others. Here's some really cool pictures of some supercell thunderstorms. They look way more intense than regular thunderstorms, regular cumulonimbus clouds. Let's see. Beyond just the spawning of tornadoes, some of these severe thunderstorms might have lightning associated with it. We kind of spoke about lightning a little bit in the last video, about the different types of lightning, but here are some facts about lightning. Lightning is 5 times hotter than the surface of the sun, which is incredible. It causes about 7,500 forest fires a year, and on average can cause 300 injuries and somewhere between probably 90 and 95 deaths per year. So lightning, very dangerous. That's why if you hear thunder and you don't see lightning, get indoors, get to a place where it's safe, because lightning is very dangerous. Next, with severe weather, we've already spoken about hail before and how hail can form. Hail can cause tremendous damage to crops, vehicles, things like that, because it's solid ice chunks falling from the sky. It's very common in the springtime, summertime, less common in the fall, because you need a large juxtaposition between temperature to really good conditions for hail formation. Again, hail forms in the process of like rain freezing, melting a little bit, freezing, melting a little bit, as an updraft keeps it up in the air. And then once the ice is heavy enough that the wind can no longer keep it up in the atmosphere, it falls to the ground. That's why in almost all hailstones that we find, if we split them open, you'd find little rings of freezing and refreezing, kind of like tree rings, to tell you kind of how many times it went through that cycle. Wind in general, you can get incredibly strong downdrafts or downbursts, as it might be called. They're extremely violent movements of wind speed down toward the ground that can be over 160 kilometers an hour. These are strong enough to push airplanes very far down from when they were kind of up in the air surface. Downdrafts are very dangerous if you're trying to land an airplane, like in a little image here. It's like an airplane's coming to land, and that downdraft can push it off course and make it miss its landing. So if we're trying to land an airplane, one of the things that we're looking out for is to make sure we're not trying to land in severe weather, because these downbursts are very hard to predict the moment in which they're going to happen. So winds in general can be very dangerous with severe weather. Speaking of wind, let's double back to talk about how tornadoes actually form. Wind speed and direction might change very suddenly with height. The change creates a horizontal rotation in the lower bit of the atmosphere, and then strong updrafts will tilt that rotating air from a horizontal position to a vertical position. You need very flat areas for these tornadoes to form. If you have any sort of higher topography, like mountains, things like that, it's a lot harder for tornadoes to form because you need a good, strong area of flat wind to be popped upright for that tornado to form. So if you don't have an area that's wide open enough for that flat wind, it's very hard for that to occur. That's why many of the states in the country that see a lot of tornadoes are in the Midwest, where it's really flat, not a lot of elevated topography to kind of get in the way of those tornadoes forming. Here's a good image that shows you how you go about getting tornadoes. You start with some sort of horizontal wind. It's kind of pushed upward because of rising air. And then the spin of the air becomes kind of incorporated in that main updraft of a thunderstorm. If we know where the thunderstorm updraft is compared to the downdraft, the tornado generally is going to sit kind of on the back half of that thunderstorm. Because remember, the updraft is behind it, pulling in moisture. It's raining in the front end of it. That's why almost always we'll get, the rain and the hail ahead of a tornado, because a tornado is going to live in the updraft portion of a thunderstorm. We used to rank tornadoes based upon how long they were on the ground and their wind speed. We call it the Fujita Tornado Intensity Scale. It ranks and classifies tornadoes according to their path of destruction, how long they were on the ground, their wind speed, and the duration. And then they adjust this to make it more appropriate, where they change it to the enhanced Fujita scale, where they change the ranking of tornadoes based on how much damage it did. The difference between this, the enhanced Fujita scale, excuse me, and the Fujita scale is that the enhanced one takes into account other factors that the original Fujita scale didn't do. So the enhanced one, it was developed and implemented in 1970. Oh, I'm sorry. The original one was put in place in 1971. The enhanced one was 2007. So again, the enhanced one, meteorologists will come in after the fact, they'll assess the damage, and then they establish what level of tornado that they were dealing with. Here are some pictures of some example tornadoes. So here's an F1. Here's an F2. They look very similar, a little more formation at the top of this tornado. F3, a little thicker. F4 was starting to get much more wide. And then this was one example of an F5 tornado. Here's a rule of thumb when it comes to tornadoes. If you're looking at a tornado and you see it looks like almost just like a finger on the ground, it's not, I mean, it's a strong system. Don't get me wrong. Every tornado is dangerous, but it's the tornadoes that have kind of a V shape. Those are the ones that are the most dangerous because those are generally the widest tornadoes that you're going to see. Whereas these F1 very skinny narrow tornadoes are less dangerous in the sense that they are, taking up much, much less space. So that's tornadoes. Tropical storms, they're a totally different beast. While normally peaceful, tropical oceans, we can produce the most violent weather systems. Our hurricanes, our typhoons, our tropical cyclones to form. We need specific conditions to get these hurricanes, to get these tropical storms. You need a lot of warm ocean water, and you need some sort of vertical lift of the warm air that keeps rising. Now we know if the water's warm, it's going to evaporate, and then that evaporation will, lead to some condensation, get us some clouds. And there's always a lot of instability in the tropics here. So there's always going to be some sort of low pressure hanging out. So you need the warm water and some vertical lift because of that low pressure. There are different stages to the life cycle of a tropical storm. The first one, the formative stage, the warm air rises, get some rainfall going on, you get a little air circulation. And then the first kind of stage we get is a tropical depression. The mature stage, we are starting to have moving air approaching the center of the storm. We get a lot of good rotation working around the quote unquote eye of the storm. This is where we're going to start seeing some storms at the tropical storm level, some at the hurricane level. So the mature stage, we have rotating air around the eye. The dissipation stage, the cyclone no longer is able to self-sustain. This generally only happens after it has moved over land or much colder water, so it's no longer getting a fuel source. So here are some pictures of a couple hurricanes. Top left here was the one that did most of the work for us. This is Hurricane Sandy. In the top left, this was from 2012. And I'm not entirely sure, but I have a sinking feeling the bottom right picture there was Hurricane Katrina. We'll watch a video on Hurricane Katrina a little later in class. There's a picture or two of some tropical storms. So this is kind of the front end of it. That just massive wall of clouds on that hurricane. What are the main dangers of hurricanes? Well, a lot of people think it's the wind. The reality is it's the storm surge. It is the amount of water that that hurricane is going to displace and push on the land. So while winds can be dangerous, it's the storm surge that is the most devastating part of tropical systems. So we've done some supercell thunderstorm talk. We spoke about how tornadoes are formed and how we rate them, and a little bit about hurricane development. The last thing we need to mention is weather that can last or persist or recur for a long period of time, that even though it may be relatively mild, it can be destructive the longer it hangs out. So some recurrent weather patterns are like floods. You get too much rain at one time, or you have mild storms that hang out for a long period of time and give enough rain to cause flooding. Flooding damage can do a lot of damage. It can wreck homes and things like that. Droughts, extended periods of time where you don't get a lot of rain. It dries out an area, makes it a little more arid, makes it more susceptible to maybe wildfires, things like that. Some places around the world, you could have droughts for weeks or months at a time. It makes water way more scarce. So, you know, in areas that are a little more arid around the world, that scarcity could lead to kind of life dangerous situations where people are going to, you know, beginning running out of water that they need to survive and grow crops. So drought can be very dangerous. Floods, droughts, recurrent weather. Cold waves, where you have periods of time where the temperature is really, really low. Generally, this is brought upon by high pressure systems, continental polar Arctic region air kind of shifting a little more south. Heat waves, the same thing as a cold wave, just, you know, it's warm. Generally, the heat wave, extended period of time above average temperatures. You have a large high pressure system kind of in place that kind of forces these situations to occur. Let's see. I'm just skipping ahead here to see what we got here. And then what can actually cause these recurring weather patterns to develop is you have the jet streams kind of moving in place, kind of position themselves in certain regions. That way we could have polar air in one location, warmer air in one location. Ideally, it just has to do with what are the air mass doing in an area to kind of give us the information about recurrent weather. And these are some examples here. So if you have large pools of extremely cold air in an area, you can get cold waves. If you have large areas of really warm weather, you can get warm, you know, heat waves. Sinking air from strong high pressure systems can cause droughts. Lots of thunderstorms, heavy precipitation can cause floods. So this last little chunk, these last like couple slides here about recurrent weather, it just says that even though the weather might be a little mild, quote unquote, it can become destructive if it persists for a long period of time. So I know there was a lot of stuff in this video. I encourage you to go back and watch it again. We spoke about supercell thunderstorms, how they work, tornadoes and their formation, a little bit about hurricanes and recurrent weather. So 4 main topics from this that you're going to want to kind of double back and look through again. So that's all for me. That's all I have for this video. Thank you for making it to the end of our meteorology unit. If you have any questions, please go ahead and ask. If not, have a good rest of your day, and we'll see you next time. Bye-bye.